Hello world, this is Doug Purcell speaking, and I will be your trainer for this Python series. To tell you a little about myself, I have a BS in computer science, wrote 2 books about Python, and do technical training. You may be wondering what exactly is Python. Python is a popular, high-level, general-purpose programming language that's used at various tech companies such as Google, Facebook, Netflix, and Dropbox. Popular use cases of Python includes data science, data analysis, DevOps, web development, and cybersecurity. In this video training series, we'll master the fundamentals in Python, and you learn how to get Python installed, what integrate development environment to use, aka IDE, the basic data types, control flow, iteration, and how to do modular programming in Python. So let's go ahead and get started. All right, let's go ahead and learn how to get Python set up on our operating system. Python is cross-system compatible, meaning that you can install Python on Windows, on macOS, or Linux-based operating systems. To get all the information you need in order to get Python set up on your machine, go to python.org/downloads, and you should come to a website that looks like this. Python.org is the official website for Python. So if you want to get the latest information about Python, perhaps you want to get more involved in the Python community, or if you want to get the latest news about Python, then go to this website. This is your ultimate resource. So when you come to the website, at the very top, you'll see a button that asks you to download Python. And at the time of creating this course, Python 3.8.3 is the most latest version of Python. You'll also see links to download Python for various operating systems. So go ahead and click on the operating system that's compatible with your computer. All right. So right here, you should see the latest releases of Python. So I want the latest version of Python. So I just go and click on 3.8.3. It gives you the latest updates about the language, all that good information. I'm just going to scroll down all the way to the bottom. And then what you see are the various installers for Python. You'll see the Mac OS 64-bit installer. If you have a Mac OS, go ahead and click on this and run the installer. If you have a Windows-based machine, which I do, go ahead and click on the appropriate version for your machine. I want the Windows x86 64-bit, so I'm going to click on this file. And then as you will see, it's an executable file. So I'm going to go ahead and open that and just run it. And then a very important step to remember is to make sure to add Python 3.8 to path. What this will do is it will allow us to run the Python interpreter via the command line. Go ahead and click on the install Python now, and just let the Python installer do its thing. You can sit back and relax, grab a cup of coffee, and just chill and hang out until Python has officially installed on Windows, which will take anywhere from 30 seconds to a minute, depending on your computer. So once Python is installed, go ahead and exit out of the dialog box. And then what I want to do next is to test it. So I'm going to scroll down to the left-hand portion of my screen, and I'm going to type in the word CMD, which is short for command prompt. Go ahead and hit enter, and then boom, the command prompt opens. Now, if you're using Mac OS or Linux-based operating system, then what you want to do is instead open up the terminal. So search on your computer for the terminal application and go ahead and open it. And then the next step to do, regardless of what operating system you're using, is to type in Python. And again, hit enter, and then boom. If Python has successfully been installed, then what you see this output right here, which represents the latest version of Python, which is Python 3.8.3 at the time of producing this video. So if you got this far, then congrats. You have successfully installed Python. The next step is to go ahead and get more acquainted with Python. Because once you install Python, you don't only get Python, you also get an IDE. You also get the Python core library. And plus you also get a couple of other tools that will help make your development a lot more easier, which is what we'll learn in the next video. Now that we got Python installed, let's go ahead and learn more about the tools that come bundled with Python. Since I'm using a Windows-based operating system, I'm going to scroll down to the bottom left-hand corner and then type in CMD, which is short for command prompt. If you're using a Mac OS or Linux-based operating system, go ahead and search for the terminal application and then get that to run. Once there, type in Python and then hit enter. And then as you'll see, we'll get this various output. What exactly does this mean? When you see the degree gradient signs, that means that you're in the Python repo, which is short for read, evaluate, print, and loop. I love using this tool to show students how to get more acquainted with the Python syntax. I love it for the reason that you can type in syntax and the Python interpreter will automatically tell you if that input is correct or not. So go ahead and type in just some very basic mathematical expressions. Something as simple as 5 plus 5. Or try 10 star 10, which is 10 times 10. Or 5/2.5, which is the same thing as 5 divided by 2.5. And then as we can see, we'll get this instant feedback from Python. Now, if we were to type in incorrect syntax like this right here, then the Python interpreter will give us correct feedback. It will give us feedback that this is a syntax error because you can't type in an expression like this. And not only do we get an error, but the Python interpreter has this caret that gives us an indication on where exactly that error happened. You could use the up key to get the most recent feedback, and then we can correct this. And there we go. So the Python interpreter is a great tool to use when you're learning the syntax of Python. I highly recommend it. To get out of this tool, use the keyboard shortcut of Ctrl+Z and go ahead and hit enter. And then as you can see, we don't have the degree gradient signs no more, do we? We're back in this path on our computer. So if you want to change paths via the command line, you can use various commands such as cd, which is short for change directory. And this will allow us to change into the desktop. You can use dir on Windows or ls on Linux and Unix-based operating systems to list the files that's in a particular directory. And if you want to go down a directory, you can use cd, which again is short for change directory, followed by 2 periods and a /. So as you can see, we're back in Doug. I go down another one, we're in users. If I want to go back to the desktop, I can do cd, which is change directory, into Doug/desktop. And then boom, we're back in the desktop. So these are commands that you can type in command prompt or in terminal. And the benefit of doing this is that it's faster. You can use the file system, you can point and click and get to certain directories on your computer. But by doing so, it's a little bit more work. If you get really familiar with the commands, you can be a lot more efficient in your workflow. Let's go ahead and learn about pip, which is another tool that comes bundled with Python. To execute this tool, type in pip via the command line. And then what we get is all this output, right? So scroll back up to the very top, And then as you can see, we have instructions on how exactly to use this program. So pip is the name of the command line tool. And then if we want to go ahead and execute something, we have to use the name of the program followed by a command and optional options. And this right here are all the commands available to us in pip. And as you can see, we have details on what exactly these commands do. If we need to install additional packages, then we can use this install command. If we want to uninstall a package, we can use uninstall. If we want to just list all the packages that we have downloaded in Python, then we could just use list. Let's go ahead and test this out so that we're confident that we understand how to use this tool. In command prompt, I'm just going to type in pip followed by list, and then boom. What you see is all of the packages that we have downloaded in Python, along with the version information as well. Anytime you need to install an additional package, just use pip followed by install in the name of the package. Let's say that you want to get into data science and download pandas, which is a very popular library that's used in data manipulation and data analysis in Python. You can use pip install in this pandas and then hit enter. And as you can see, pip will take care of everything else for you. So it's very quick, very efficient. And some more goodies that come bundled with Python is the Python core library. So let's go ahead and open up the Python interpreter by typing Python and type in import math. And then math dot sign of 90. So what's happening? So I imported this module in Python, which is called math. And I can call the various functionality in that particular package, which in this case is sign. So the Python core library is automatically shipped with your Python installation. And it contains functionality for mathematics. It contains functionality for operating systems. It contains functionality for generating pseudo-random numbers. It contains functionality for a whole host of features to be implemented. And the good thing is, it's available to you for free once you download Python. It's not going to cost you a dime. And from a developer perspective, this is very useful because if you have certain functionality that needs to be coded, and if you're on an extremely tight deadline, then wouldn't it be nice to have code that's been tested, that's been vetted by professional developers, and that's ready to be used at your disposal? I think so. So the Python core library is a massive archive of high quality code that you can import into your Python programs and make use of right after you install Python. So go ahead and get more familiar with the Python interpreter. We'll be using it a lot more throughout the rest of this training series. If you can't run a Python script, then there's no point in programming in Python. So we'll next learn how to create our own Python scripts and how to invoke or run it via the command line. So let's go ahead and open up a simple text editor. If you're on Windows, use Notepad or use the most basic program for your operating system. So I'm going to the search function. I'm going to type in Notepad and then hit enter to invoke this basic text editor. And I'm going to type in print followed by hello world and make sure to wrap in the text within single quotes. The next step is to save the file to a location that you can easily retrieve. So I'm going to save the file on my desktop. So click on File, Save As, go to the desktop, and then type in hello underscore world.py. And why .py? As we can see, we have the Python logo right here. So .py indicates that this file is a Python script. Just think of the various files that you have downloaded on your computer. If you're using Microsoft Word, then the extension will be docx. Or if you're creating a simple text file, then the extension will be .txt. So to indicate that you're creating a Python script, make sure that the extension is .py. Once that's done, go ahead and open up Command Prompt on Windows or Terminal on Mac OS/Linux. And what I want to do next is I want to change into the path or the location of my file. So since my file is located on my desktop, I'm going to cd desktop, hit enter. If you're on Windows, you can use dir, which is a command to list all the files in this particular directory. Or if you're using Mac OS or Linux, type in ls to list the files. And as you can see, I see that hello_world.py is listed there. So the next step is to go ahead and run the file. So the syntax for doing so is Python, followed by the name of the file, .py. And then go ahead and hit enter. And as you can see, the output of hello world was displayed. This is how you create and run scripts in Python via the command line. You can run 1, 2, or multiple scripts via the command line by using this technique. In the next lesson, we're going to learn how to speed up our programming by using a sophisticated integrated development environment, also known as IDE. Let's go ahead and learn about one of the most important tools that a software engineer will be using in a day-to-day process. That tool is called an integrated development environment, aka IDE. Python has a plethora of IDEs that you can use, such as Atom, Sublime, Vim, Eclipse, Visual Studio, and even Emacs. An IDE is a tool that a developer can use to expedite their programming process. The IDE that I use is PyCharm, and you can go ahead and download it from jetbrains.com/PyCharm/download. As you can see, it comes in 2 different flavors. You can download the professional version or the community edition. The professional tool is commercial software, and it comes with more functionality for data science and web development in Python. If you want to test it out, you could use the free trial. The one that I recommend for beginners is the PyCharm Community Edition. It's free and open source and comes with the functionality that you will be needing. So go ahead and click the download button for the PyCharm Community Edition. And once the program has finished downloading, go ahead and run the executable file. All right, everything is nice and downloaded. So I'm going to go ahead and open the .exe file and then just follow the instructions in the dialog box. So click next again, click next, click install, and just wait for PyCharm to go ahead and download on your machine. All right, so go ahead and click Run PyCharm Community Edition, followed by the Finish button. And now PyCharm should be running. Look at that. So we can go ahead and click on the blue button for OK. And then if you want, we can use 2 different themes for PyCharm. I'm going to go ahead and click this one right here. So go ahead and click Next Feature Plugins. And I just want to go ahead and start using PyCharm. So I'm going to skip all of these steps right here. I'm not going to install plugins because you can always go back and do that later. So I'm going to click the Start Using PyCharm button and then wait for PyCharm to finally load. All right, so the first thing we want to do is to create a very simple script. And we need to put our scripts inside projects. A project in PyCharm is the same thing as a folder or directory. It's just a container for all of the files for your particular Python project. So go ahead and click on Create New Project. Go ahead and type in the name of your project. And let's call this Python underscore fundamentals. Go ahead and click on create. All right. So once PyCharm has officially loaded, we can see that we have that Python underscore fundamentals project right here. And as mentioned previously, our project is simply just a folder that we can put all of our files in. So let's go ahead and add a script to this project. I'm going to right click on this, select new, select Python file, and then I'm going to go ahead and give it a name. Let's call this simple underscore program, because that's exactly what we're creating. I'm going to go ahead and click cancel because I don't want to add this to Git. Git is a tool that's used for version control, but in this training series, we won't worry about using Git. So the next thing I'm going to do is just put simple print statements in this program. I'm going to put Python. I'm going to put print version. And I'm going to put print 3.8. And then the next thing I want to do is I want to run this program. So I can click on run. I click on run again. And I need to click on edit configuration because I need to configure PyCharm to work with the Python interpreter. So I can go ahead and click on the plus icon. And then I'm going to go ahead and click on Python. And then what we will need to do next is we need to find the path to where our script is at. So I'm going to click on this folder icon, scroll down to the name of this project, which is Python Fundamentals. And then I'm going to click simple program.py. And as you can see, the path of the program is loaded. I'm going to go ahead and click apply. And then I'm going to go ahead and click run. And then as you can see, all of the information is displayed. And after you ran the program the first time, you can always go to this green triangle here and just click on it. Or a more faster way is to use the keyboard shortcut of Shift plus F10. And as you can see, we have ran a very simple Python program within PyCharm. And just another tip for PyCharm, all of the Python programs you create are located in this folder called PyCharm projects. And if you want to get the path to this folder on a Windows-based operating system, just go ahead and right-click on it and select copy full path. And then we'll be able to know exactly where our PyCharm projects are located, which will be in this folder. And if you hover your mouse over this folder right here, you can see the exact path to where this project is located at on your machine. This could be useful if you're using a version control software like Git, and you need to know exactly where your file is located so that you could push or add that file to our remote repository online. So going forward, we will be using PyCharm to create the programs in the rest of this training series. So go ahead and get more familiar with PyCharm. Go ahead and add a couple more print statements so that you get very comfortable with using this IDE. In the next lesson, we'll learn about how to manipulate numbers in Python. Let's go ahead and get more familiar with some of the basic data types in Python. Let's start with a data type that we all have a reference point from, which are numbers. This is something that we've learned since grade school. We've learned how to add, how to subtract, how to multiply, and how to divide numbers. So this is a common reference point for everyone. Let's go ahead and learn how to implement this in Python. I'm going to go to the Python interpreter. So I'm going to type in cmd for command prompt, type in Python to run the Python repo, and then this is where I can experiment and get more acquainted with the Python syntax. So go ahead and add several numbers together. Do something like 5 plus 10 plus 100. Do something like 5 minus 3. Let's go ahead and do 6 star 9, which is the same thing as 6 multiplied by 9. Let's do 2 divided by 3. Python also comes equipped with several additional operators. If we wanted to emulate the raised to the nth power, we can use this syntax right here, 5 star star 2, which is the same thing as 5 raised to the second power, or 25. 10 star star 10 is 10 raised to the 10th power. We could also use 5 / 2, which is the same thing as the floor operator. So the floor operator in Python is similar to the floor operator in mathematics. If we have a number 5 and we divide that number by 3, then what happens is 5 is the dividend, 3 is the divisor, and then 3 goes into 5 one time. And then the remainder is 2, bring down a 0. And then it will be 3 point from decimal point, 6, and then etc. This is the same thing as the floor operator in mathematics. So whatever follows the decimal point is truncated or removed. So in this case, the 6 is gone, and the result would just be 1. So let's go ahead and test this. Let's say 5 / 3, and as we can see, the remainder is 1. And if we want to emulate modulus mathematics, then we can use the percent sign. We can do something like 5% 3, and then as we can see, the result in this case is 2. So again, let's go ahead and visualize this. 5% 3 is saying that 5 divided by 3. So 5 is the dividend, 3 is the divisor, 3 goes through 5 once, and then the remainder is 2. So with the modulus operator, what we want is the remainder. This right here. That's what we get when we do the modulus operator in Python. So if we do 9% 3, what would be the answer? The result would be 0, because 3 goes into 9 3 times with 0 remainder. So when would we want to use this operator? If we wanted to test to see that if a number is even or divisible by 2, we can always use this percent operator. So 10% 2 would be 0. Therefore, we can conclude that 10 is indeed an even number. Let's do 11% 2. In this case, the remainder is 1, because 2 goes into 11 5 times with a remainder of 1. So we know that 11 is a composite number, or odd. Composite numbers are not divisible by 2, and therefore we'll have a remainder. So this is how these operators work in Python. So let's work on a more complex example. Let's say that I want you to compute the following. I want to say 5 squared plus 10 squared, and I want to divide all that by 2. So the result should be 25 plus 100 divided by 2, or 125 divided by 2. Let's go ahead and implement that in Python. This helps us to get more acquainted with the syntax of Python and to see more complex and hopefully more practical examples and how we can use Python to solve common everyday problems. So this is one approach on how I would go about doing this. I would do 10 * 2 plus 5 * 2, because remember that * indicates raised to that particular power. And I'll make sure to group this within parentheses, these symbols right here. And this makes it very explicit that we want to do 10 squared plus 25 and then divide it by 2. And as you can see, we get the result of 62.5, which is correct. So parentheses help to group expressions together, and plus it makes our code more readable. If we didn't include the parentheses, then let's see what would happen. let's go ahead and just remove the previous parentheses. And in the Python interpreter, you can retrieve the previous input by using the up and down arrows. So as we can see in this case, we get 112.5. So what's exactly happening? Well, since we didn't include the top expression or the numerator within parentheses, then what happened is that the Python interpreter said that, okay, you want to do 10 star star 2 plus 5 star star 2 divided by 2. So in this case, we did 100 plus 25 divided by 2. That's what this expression did, as we have verified right here. So be very careful when you want to group expressions together. Use parentheses because they help make your intent a lot more clear, and it'll also help you out when you're putting together formulas and you don't want to make an error. So go ahead and get more familiar with the Python interpreter. Just go ahead and explore. Let's go ahead and look at another example on how we can use Python to quickly get the result of something that we may want to know. Let's say that you purchase a car in the state of California. And let's assume that the car costs you $10,000. How much would the sales tax for that car be? Let's first learn about variables in Python. So I'm going to create a variable called car_price. And I'm going to set that equal to 10,000. And I'm going to create sales tax, sales_tax, and set that equal to 7.5, which is the sales tax in the state of California, divided by 100. Because we want to represent the percent as a decimal. So to do that, we need to divide that by 100. And then if we want to compute the amount we have to pay, then we can create a third variable called amount and set it equal to car_price times sales_tax. And then we can get the output just by typing in the name of the variable amount. And as we can see, we have to pay $750 for the sales tax in the state of California. So variables in Python are similar to variables in mathematics. In algebra, we learn about variables such as x squared plus y squared. X and y are variables because the values are contingent to change, hence variable. Some examples of variables in everyday life is the temperature for one. During the morning time, it's typically more cooler, and then as the day progresses, the weather gets more hotter, so that variable of temperature increases. And then again, during nighttime, the temperature drops, so that variable decreases. So that's an example of a variable in everyday life. You can even say that someone's mood is a variable. Sometimes someone could be happy, sometimes they could be sad, etc. So think of emojis because emojis represent the various emotions that humans can have, and that's something that's contingent to change. So in this case, car_price is a variable in Python because it stores a value. We can replace car price with anything we want. We can say that the car price is equal to, let's say, is equal to 25,000. And the sales tax will remain the same. So what we can do next is to generate the statement amount is equal to car_price times sales_tax. Now, as we can see, the sales tax has increased because the car price has increased from 10,000 to 25,000. So more than double, as we can see by the output here. So variables are used to store values in Python. And not just in Python, in many programming languages, because when you program, you will be inherently modifying data throughout the course of your code. And a variable is a way to store that value at that particular instant. And variables in Python, like variables in mathematics, are contingent to change. So go ahead and keep experimenting with the Python interpreter. It's okay to go ahead and make errors. If you make a syntax error like something like this, then go ahead and look at what the Python interpreter tells you. When you see the caret, that indicates where that error has occurred within your code. Once you see it, go ahead and fix it. Do that a couple of times so that you can get very comfortable with dealing with the numbers in Python. Once you have done that, the next step is to go ahead and put together a more sophisticated program that does something a little more practical. Let's go ahead and write a Python script that computes the Pythagorean theorem. This is an ancient theorem that states that c is equal to the square root of a squared plus b squared. Why do this? Why should we write an ancient script in Python? There's 3 key reasons on why to do this. By writing this theorem in Python, you'll get more comfortable with the syntax of the language. You'll also learn how to think more like a computer programmer, and you can start off by building something simple so that you can gain the confidence and experience to build something more complex and more practical to your use case. So we can go ahead and enter in some values for a and b so that we can test what the result is. So if a is 5 and b is 4, c is equal to 6.4, and if a is 10 and b is 15, then the result is 18.03. Let's go ahead and switch to PyCharm. And under the Python_fundamentals project, let's right click, select new Python file, and then let's enter in py_theorem. And then hit enter and click cancel because I do not want to add this to Git. So the first thing that we need to do is learn how to take the square root of a number. When we download Python, we get access to the Python core library, which is a suite of modules that we can import and use to draw our own programs. So let's go ahead and import the math module. And then to test how this works, let's do math followed by .sqrt. So there's a couple things I'd like to mention. When we did the math followed by dot, this is something in programming called introspection. The IDE introspects this object and sees the related functionality associated with this module. So if we were to type sqrt, then we can see that square root, which is what sqrt is short for, is a function in this particular module. And then if we want it, we could just hit enter on PyCharm. And I'm just going to type in math.square root of 9. And I'm going to store this in a variable called a. And then in order to see the output, I'm going to pass in that variable into the print function, because the print function allows us to display the output through here, this part of the IDE, which is called the console. So I'm going to go ahead and click on run, scroll down to run, and then as we can see, the py_theorem script is loaded. Go ahead and click on that, and as we can see, 3.0 is the result from doing math.sqrt of 9. So that's how you take the square root of a number in Python. You import the math module, and then you call math.sqrt. So let's go ahead and write the formula. I'm going to create 2 variables. A is equal to 5, and b is equal to 4. And then I'm going to create the third variable, which is c, and set it equal to math.sqrt, because I want to take the square root of a squared, which we can do in Python by using a**2 plus b squared, which we can do by b**2. So when we print the result, we use Shift plus F10 as a shortcut once we run the program. So when we get the output, the result is 6.40312, etc. If we want to truncate all of these remaining decimals, we can pass in the result into a function called round. And then what we can do is we can specify how many places we want to round to. We want to round c to 2 decimal places. I'm going to hit Shift plus F10 again. And then as you can see, we got 6.4 as the result. And then let's go ahead and test this again to make sure that we have wrote our equation correctly. Let's say that a is equal to 10. Then we'll change the variable of b is equal to 15. And let's go ahead and save this and run this again. And as we can see, the result is 18.03. So we have successfully converted Pythagorean theorem into a very simple Python script. Congrats on implementing the Pythagorean theorem in Python. Since we're on a winning streak, let's go ahead and write another script that involves numbers. Let's imagine that you're going on a vacation and you want to figure out how much your American dollars will be worth in a different currency. You go to this website, exchange-rates.org, which lists the values of USD to different currencies. So we can see right here that 1 USD is worth 0.89003 euros, and worth this amount of Japanese yen, and this amount of Canadian dollars. So let's go ahead and convert this logic into a Python script. But before we do that, let's go ahead and think, what variables do we need? And how should we structure our program? One approach is that we can create 4 variables. We can create a variable for US dollars, and then we can create 3 variables, and then we can create the variables that stores the conversion of the USD to the different currency. Let's say that we just want to compute the conversion of USD to Euro, Japanese yen, and Canadian dollar. Let's go ahead and write a script for this in Python. I switch back to PyCharm, and then I'm going to right-click, select New, Python file, and I'll just call this Currency Converter. And next, I'm going to create my 3 variables. So I'm going to create a variable called US_dollars, which represents how much money I have. And then I'm going to create the other 3 variables, which represents the conversion from USD to that particular currency. So for Euro, I'm going to say US_2_Euro. And at the time of creating this video, that conversion rate is 0.89003. As for USD to Japanese yen to JPY, that will be equal to 107.95507. And last but not least, USD to Canadian dollar, so USD_2_CAD equal to 1.35728. So if I want to compute the conversion of US dollars to Euro, I can just have a print statement and then put US_dollars times USD_2_Euro. And then I can repeat this process for the Japanese yen and Canadian dollar. So I finished writing my program, and the final step is to go ahead and run it. So I'm going to click on run, and then select the Python script that I want to load, which is currency_converter. And as you can see, the conversion rate is done. So if I were to convert 500 US dollars into euros, the result would be 445.015 euros. If I want to convert it to Japanese yen, then I have 53,977.535 yen. And then last but not least, 500 USD to Canadian dollar is 678.64 CAD. So not only we created a currency converter, but we also learned how to think more like a computer programmer by logically structuring our thoughts and breaking our program step by step. Let's go ahead and improve upon this program. And let's go ahead and learn how to make it more dynamic by reading in user input. So we got the currency converter to work. But one issue with this program is that, say that we want to convert 700 US dollars, or perhaps we want to convert $1,000 US. We had to keep reassigning that variable, which could be a tad bit annoying. Wouldn't it be great if there was a way for the program to interact with the user? Well, there is, and I'm going to show you a built-in function in Python that does just that. So I'm going to switch to the Python interpreter. I'm going to type in CMD for command prompt, type in Python, and then boom, we're back in the Python interpreter. So to illustrate how this function works, I'm going to just type a simple statement, and then I'll explain what's happening. So what's happening is that I've created a variable called your_name. I set it equal to input, and then inside of this function, we have some text. So I enter in my name, which is Doug, and then if I were to type the variable, then what you see is the input I've entered. So this is a way for the user to interact with the program. The program prompt me for input, in which I provide it, and then that input could be captured in the variable and then displayed. There's only one problem in this case. I'm going to pass in the variable your_name into another built-in function in Python called type. As we can see, this data type belongs to str. str is short for string. Anytime you have some type of data encapsulated within single or double quotes, then that's a string data type. We'll learn more about the string data type in a future lesson. But in the meantime, just remember that it's any type of text that's encapsulated within single, double, or even triple quotes. And this too is a string. We can always verify the data type of a variable by passing it into the type function. And as you can see, str again. But if I were to pass in 10, then this belongs to the int class in Python, because this is an integer, which is similar to mathematics, a negative or positive whole number. Or if I were to pass in 10 point all this, then this belongs to the float class, because a floating point is a type of number, but the difference between that and int is that it has decimal points. For more precision, that's when you want to use an int over a float, if precision is very important to you. So going back to this example right here, if I were to pull up this right here, and if I were to pass in 8, then what would happen is the result will be a string, in which we can verify because it has the single quote around it. So that's a problem. Let's say that we want to pass in just numbers into our program. We don't want to pass in an integer and have it converted to a string. How can we get around that in Python? Well, let's go ahead and create another variable called magic_number. And then in this case, what I'm going to do is I'm going to pass the input function into another function called float. And I'm putting in a space between number and the single quote, because when the program runs, I want a space to be shown right here. If I didn't put a space here, then my input and this letter R will run together, which I think will be a little bit more difficult to decipher. So I'm going to pass in 7.269, and then when I display magic_number, it is indeed a floating point. And we can verify that by passing that into the type function. All right, so we're making progress. So we now know how to pass in a number type to our program. In this case, we want to pass in a floating point. So therefore, we're now equipped with the knowledge to go back to our previous program and to update it so that the user can pass in an arbitrary input to the program. So I'm going to exit out of the Python interpreter. I'm going to copy all this So I'm going to use the keyboard shortcut of Control plus A to highlight all of this. Use Control plus S to save this. And then I'm going to create a new file. So I can do a right click, new Python file. And then I'll say enhance converter. And click cancel. And then copy and paste it, or Control plus V. So we duplicated the previous program into a new file. And the one modification we want to do is I want to ask the user how much dollars they want to convert. I don't want to hard code that result in a variable. I want the user to be able to pass in whatever number they have in their mind into the program. So what I can do next is I can change this right here. And that's it. So when I run the program, this prompt will display to the user. It will say, enter in how many US dollars you have. And then I go ahead and enter in the amount. And then these conversions will automatically be done and therefore printed as well. So I'm going to go to run, and select enhance underscore converter. Then I'm going to type in the amount of USD dollars I have. So I'll say 550. Then as you can see, the result is displayed. I want to do this again. No problemo. Shift plus F10. Let's say this amount. Boom. It's all automatically done for us. So what we did was we just updated that previous script that we did so that our program is more dynamic. Let's go ahead and keep learning about the different data types in Python. We've learned about numbers, but there's a lot more data types that we can make use of when we're writing our Python scripts. Let's go ahead and learn about a new data type in Python called the Bool Datatype. So sometimes I feel that a simple code statement is worth 1,000 words. So I'm going to create two variables, x comma y is equal to true comma false. And you can create multiple variables in Python on a single statement. And then I'm going to use that built-in type function. And I'm just going to pass in these variables into them. And then as we can see that the type of x and y are bool, which are short for Boolean. So this data type is the namesake of a pioneer in computer science called George Boole. And he created a branch of mathematics called Boolean algebra. This branch of mathematics had led to significant breakthroughs in the realm of computer science. It's so significant that, in fact, every major programming language implements the Bool data type. So C, C++, Java, Ruby, etc. So if you understand the fundamentals of the Bool data type, then you can apply that logic to various other programming languages. So in other words, it's a good investment to learn it once. So to get a better understanding of how the Bool data type works, let's go ahead and backtrack to some other data types that we created. So here, I created three variables which stores an int, a float, and another int. And we can apply the basic mathematical operators to these data types, right? And by doing so, we manipulate their values. We can combine them to form more complex expressions, and we can use them to solve equations to perhaps help us calculate the sales tax of our car, or to even calculate the interest on our credit card. So the operations such as the plus sign, or the hyphen for subtraction, or the asterisk for multiplication, or the forward slash for division, or the percent sign for modulus operator, or the forward slash sign for the floor operator. These are operators that can be applied to the number type. Let's go ahead and switch back to the Bool data type. Compared to numbers, numbers can have an infinite amount of possibilities. If we were to go back to grade school, remember the number line. we had this line of numbers. In the middle, we have 0. And then to the right, we have positive numbers up into infinity. And then to the left of it, we have negative numbers that goes all the way to negative infinity. So there are an infinite possibilities of what type of numbers could represent an integer, or even a floating point type as well. However, with the Bool data type, we literally only have two options. We can have true, and we can have false. That's it. Those are literally the only values that you can have for the Bool data type. Just two. It's binary. So compared to the numbers which can have an infinite amount of values, the Bool data type can literally only have two. A lot less to remember, right? So that should make our job a lot more easier. And compared to the number data types, the Bool data type also have operators as well. And those operators are a little bit different. You don't add Bool types together. You don't subtract them. You don't divide them. However, what you can do is you can apply logical operators to them. So in Python, here are the common logical operators that you can apply on a Bool type. You can use AND. You can use OR. You can also use negation, which is not. So these are the three common operators, but how exactly does this make sense? What I'm going to do next is to type in some statements into the Python interpreter. This right here is 100% fine. We're saying true and false. So anytime we have true and with false, then the result will always be false. We can switch the order and the result will be the same. And if we have two false operands, then the result will be false as well. However, AND will be true if and only if both operands are true. So there's only one case scenario in which AND would be true. To the left and to the right of the AND operator reduces down to true. Now, let's compare that to the OR operator. If we have true or false, then the result would be true. And if we switch the order, the same thing applies. And if we have true or true, the result again would be true. However, if we have false or false, then the result would be false. So compared to AND, OR can only be false if both operands are equal to false. And every other case will be equal to true. And then you also have the negation operator, which takes the complete opposite. So if you have x, which is equal to true, and you do not x, then what do you think would be the answer? As you might have guessed correctly, the answer would be false. And if you have y, which is equal to false, and do not y, then the result would be equal to true. So let's take another look at x. Let's say you do not x. What do you think the result would be? It would be not true, which is false, and then not false, which again is true. So you start where you begin at. The result will be true. Let's go ahead and group multiple expressions together. An expression in computer programming is something that reduces down to a single value. And the reason why we need to know how the Bool type works is that they're building blocks for creating control flow statements. Those statements that you probably heard of, such as the if-else statements. The underlying logic behind that are these data types, which is why we have to learn it, so that we can construct our if-else statements in the future. So let's go ahead and get some more practice. Let's say that we have true and false, and true or false. So let's break this down bit by bit. We know that true and false reduces down to false. And we know that true or false reduces down to true. So what will be the result? The result would be false and true, which is equal to false. So in this case, that's the answer. Let's look at another example. Let's say that we do the following. So we can stop, and we can see that the result would be false. We don't even have to evaluate this expression right here, because we know that anything that's and with false, which is this right here, reduces down to false. It doesn't matter if this expression reduces down to true or if it's false. Anything that's and with false will always be false. The only time that and can be true is if both expressions reduce it down to true. So in this case, the result as predicted is equal to false. Let's look at just one more example so that we can feel a lot better about our understanding of the Bool data type in Python. Let's say that we have A is equal to true and false and false. And we have B is equal to true and false or not true. And then we have C is equal to true and true. No worries. You won't actually see anything like this written in production. This right here just for learning purposes, so that you could get in the hang of looking at and understanding how the logic of the Bool data type works. So we have this right here. So we have three variables which reduce down to a single value, and then we and then or those variables together. So this may look complex, but a key concept to understanding a lot of computer programming is to break up the task into smaller, more digestible chunks. Don't try to look at this all at once. Instead, evaluate what A is equal to, and then B, and then C, and then simply compute the last statement, and then we'll get the result. So in this case, true and false is false, and then false and false is equal to false. So we know that A is equal to false. B, true and false is equal to false, or not true. So that again is false. And then last but not least, true and true reduces down to true. So if we have false and false, that will be false, or C reduces down to false or true, which is equal to true, as we see right here. So again, we can break down more complex statements into smaller digestible chunks so that we can make better sense of the logic. So in the next lesson, we'll build on top of what we learned about the Bool type and operators in Python. We'll also learn about relational operators, which allows us to compare values. Python comes equipped with another set of operators called relational operators. And what these allow us to do is to compare two values. So you may already be familiar with how these operators work. In mathematics, we learn about the greater than sign, which denotes that something is greater than a certain value. We also learn about the less than sign, which denotes if something is less than a particular value. We can also test for equality in Python, or if one value is indeed equal to another. The symbol to use for that in Python is a double equal. If we want to test that something is not equal to another value, then what we can do is have this exclamatory mark immediately followed by the equal sign. And if we want to test to see if something is greater than or equal to another value, we can use the greater than sign immediately followed by the equal sign. And then last but not least, if we want to see that something is less than or equal to another value, then we can use less than equal than sign. So again, these are called relational operators because they help you to compare one value to another. Let's go ahead and implement them in Python with some simple code. As you can see, I'm right back here in the Python interpreter, and then I'm just going to create a couple of different variables. Is x greater than y? So we know that x is equal to 5 and y is equal to 4. So the result will reduce down to a single value, which is true. So when using comparison operators, the result reduces down to a Bool data type. If I were to do y is less than x, then we know that the result would be true. And if I want to test for equality, or if I want to see if the value stored in x is indeed equal to the value stored in y, then I use the double equal sign. And as we can see, since these two values are not equal, the result will be false. Remember that the assignment operator, which is this, is different from the equality operator. If I want to create a variable and give it a value, I use the assignment operator. If I want to see if one variable is equal to another, that's when we use the double equalness sign. All right. So we can also do x is greater than or equal to y, or we can also do y is less than or equal to x. We can also use the exclamatory mark followed by the equalness sign to test to see if a number is not equal to another. And there we go. So we can start combining these operators together to form more complex expressions. In the previous lesson, we learned about the logical operators, so we can combine them with the relational operators. So here's an example. Is 5 greater than 10, and 6 is double equal to 9. So as we can see, we combine the relational operators. So 5 is not greater than 10, so this reduces down to false, and 6 is not equal to 9. So we have false and false, so therefore the result will be false. So let's go ahead and keep experimenting with more examples. So again, we can break this down bit by bit. 5 is indeed greater than 2, so that's true, and 3 is less than 2. And then we have 5 is double equal to 5.1. So in that case, this right here evaluates to false, so we have true and false, which is equal to false. So go ahead and experiment by combining the relational and logical operators together. Don't forget about the previous mathematical expressions that we learned as well. Feel free to combine them with various relational operators, see the result, get more familiar with typing the Python syntax, because doing so will make learning about control flow a lot more intuitive, which will be the next topic discussed. Let's learn how to implement control flow in Python by using if-else statements. If-else statements help make the program more dynamic. We can execute different statements depending on how the expression reduces down to. So let's go ahead and get acquainted with the syntax of if-else statements in Python. So I'm in the Python repo, and I'm just going to go ahead and create two variables. And then I'm going to use if, which is a reserved keyword in Python. We can't use this as a variable name because doing so will generate an error. So if followed by the expression, so x is less than 10, terminated by the colon. So this right here is Python syntax. We need this reserved keyword to denote the beginning of the if statement, followed by the expression x is less than 10, terminated by the colon. And then when we hit enter, we see that we get these three dots right here. This means that we're in the Python expression. In Python, it's recommended to indent the code block by 4 spaces. So 1, 2, 3, 4. I'm going to put the statement right here which is hello world. And then I'll hit enter twice. And then as we can see, the string hello world is printed to the screen. So this right here is the basic syntax of an if-else statement in Python. If you're coming from a C-style language like C++, then this might be a lot different from what you're used to. In Python, you don't need to use curly braces. You don't need to terminate your statements by semicolons. All you need is the if keyword, followed by the expression, terminated by the colon, and then to create your code block is recommended to indent by 4 spaces. And that's it. So let's go ahead and keep writing some code so that we get more familiar with this syntax. So if x is less than y and y is greater than or equal to 3, let's go ahead and print x comma y. So we'll print the values of x and y. And since this expression reduces down to true, because x or 5 is indeed less than 10, and y or 10 is greater than or equal to 3. So we have true and true, tying together the components that we learned in the previous 2 lessons. So if the expression reduces down to true, then the code block, or what you see inside here, that statement will be executed. If this was false, then this will not be executed. But since the above expression reduces down to true, then x and y are printed. And there we go. So what happens if the if statement was false? Well, one simple test is do if false, because false is indeed equal to false. So therefore, will this code statement right here be printed? The answer in this case is no, because the above expression reduces down to false. Therefore, this code statement right here will be ignored. So as you can see, 100 is not printed. So what happens if, no pun, we included an else block? Let's go ahead and write some code to get a better understanding. If false, make sure to indent by 4 spaces. Else. So what's happening here? We have if false, which is equal to false, so therefore the code block will be ignored. And then the control of the program jumps from here to the else block. So in this case, if the above if statement is false, then the code statement within the else block will automatically be executed. So therefore, in this case, 200 will be printed, as we can see right here. So one way to look at the else block is that if the above if statement reduces down to false, then the else block is what's executed by default. That's how the else block works. But if the above if statement reduces down to true, in that case, the else block is never executed. It will be swiftly ignored. So one thing that I would like to explain first is that I would recommend you to type in your if-else statements in the Python interpreter so that you can get the hang of the syntax. Because unfortunately, if you mess up once in the Python interpreter, then it will be difficult for you to regenerate that expression. So if I do something like if true, and this syntax is correct, but if I do else and I forget to put the colon, because that's required syntax in Python, you have to terminate the if statement and the else statement with a colon. If you don't, you get an error. So if I do that, then as you can see, syntax error, invalid syntax, oh no, And plus we have this caret right here to indicate where exactly that error happened. And I can use all the up and down arrows I want in the Python interpreter, but not gonna do me any good because I won't be able to retrieve that whole entire previous expression, which could be kind of annoying. So I'm going to switch into PyCharm to illustrate how using an IDE like PyCharm makes your life a lot easier when creating your code blocks in Python. So I'm going to switch to PyCharm. I'm going to right click, select new Python file, and then if else demos, boom, cancel. X comma Y is equal to 5 comma 10. If X is less than Y, colon, hit enter, and then look at that. PyCharm automatically puts my cursor at the spot it needs to be at. So it automatically indents it by 4 spaces. I put else, I put a colon, I hit enter, and look at that. PyCharm automatically takes care of all that hassle for me. This is why you use tools when you develop. Just like a handyman had their toolbox, and they use certain tools for certain type of procedures. A software engineer has certain tools that they too use to make the job a lot more easier as well. So I'm just going to click run, and then if underscore else underscore demos, and then as you can see, we get the result right here. So use the Python interpreter to get the hang of the syntax. Once you get very comfortable doing so, use PyCharm. PyCharm is your friend. It's a very good IDE, and it will make your job writing Python scripts a lot easier. Let's do a couple more examples so that we can still feel a little bit more comfortable with if-else statements, because these are very prevalent in not only Python, but also in computer programming in general. So it's very important that you get the hang of the syntax because you'll be using it a lot moving forward. Let's say that if X is less than Y, or Y is double equal to 9, let's go ahead and print X, else. Let's go ahead and print Y. Control S to save. What's going to be the output? X is indeed less than Y, so this right here reduces down to true, or Y is double equal to 9. Y is not equal to 9, it's equal to 10, but what we have is true or false, which is equal to ... I can hear your response at your desk. The result would be true. Therefore, the control of the Python program passes from line 9 all the way to line 10. And therefore, line 10 is executed. And then the control of the program hops from line 10 all the way outside the else block. Because if this expression reduces down to true, then the else block will never be executed. So therefore, line 11 and line 12 are ignored. And when we run this program, we get 5, 5. So we now tie together the concepts that we learned in the previous videos about the logical operators, about the relational operators. And then we finally tie them together to construct if-else statements. But there's still more to learn. We need to learn about the elif statements, which allows us to chain multiple expressions together. Let's go ahead and learn about elif statements in Python. I'm going to go ahead and create a new Python file in PyCharm. So I right click, select new Python file, and then I'm going to type elif underscore statements, then hit enter. Cancel that. So one way that I like to illustrate how elif statements work in Python is to juxtapose or to compare it to another code snippet. So let's go ahead and write a program to test to see the letter grade that our user get in the class. So I'm going to go ahead and create a variable called final underscore grade. And I'm going to set that equal to float input, and then pass in some text right here. So to jot your memory, this right here will prompt the user to pass an input into the program, and that input will be converted to a float data type. A float is a number that has decimal points. And then I'm going to go ahead and write several if statements. So if final grade is greater than 90, let's go ahead and print A. And then if final underscore grade is greater than 80, I'm going to go ahead and print B. If final underscore grade is greater than 70, I'm going to print C. And then if the final underscore grade is greater than 60, I'm going to go ahead and print D. And then else, I'm going to print, I can't even put that score, so I'm going to put a sad face. I think we all know what that represents. So I'm going to go ahead and run this program by going to run, and then selecting Elif underscore statements. And then I'm going to enter in a final grade of, I'll put 59. So as we expected, the result gives back that sad face, right? Because 59 equates to the sad face being executed and printed to the console. Such travesty. However, let's go ahead and run this program again. And let's go ahead and put 95. As we can see, we get A, B, C, and D. Why we get all these results for? I just want A. The program is buggy right now. It doesn't work as advertised. I don't want all the letter grades to be printed. So we get this result because when we pass in 95, the Python interpreter starts at line 1, prompts the user for the input, stores 95 in this variable final underscore grade, and then the control of the program passes down to line 2. So if final grade is greater than 90, so 95 is indeed greater than 90, so therefore A will be printed. No problemo. The problem with this is that we don't stop here because these are multiple if statements. So these will be treated in isolation, meaning that the program will now jump to line 4 and evaluate this if statement next. And since 95 is indeed greater than 80, then B will also be printed. And then the control will pass to line 5, and then to line 6, and then line 7, line 8, line 9. And the reason why the sad face is not printed because this if statement right here is chained with that above if statement, right? So if final grade is greater than 60, then therefore D will be printed, but the else block will be ignored. So therefore the control passes from line 8 and then jumps outside of line 11. So that's why we get all of those letters printed. We get A, B, and C, and D. The way that we can fix it is by using Elif statements. And let's go ahead and just illustrate that. So what I'm about to do next is I'm going to highlight from line 11 all the way up to line 2. And then I'm going to use a keyboard shortcut in PyCharm, Control followed by the /. And you see how we get all of these hashtags in the front of our code. A hashtag in Python indicates that we're creating a comment. A comment is for programmers to read. It's not for the Python interpreter to execute. So any code that comes after this hash symbol will be ignored by the Python interpreter. So we're in essence just silencing this code right now. So I'm going to paste what we had before here, Control V to paste, and I'm going to make some modifications. I'm going to say that we have Elif right here, Elif right there, Elif right there, and then there we go. And now I'm going to rerun this program, and we're going to see what's up. Let's go ahead and pass in 75. As we can see, we get C, right? Let's go ahead and rerun this. Shift plus F10 to rerun your program. And let's go ahead and put 65. We got D. Shift plus F10 again, and let's put 95. And we should get A. So we only get one output in these scenarios. We're not getting A and B and C and D like we did when we pass in 95 and the above commented out code snippet. And this example perfectly illustrates how the Elif statement works in Python. We have multiple Elif statements chained together, and what I mean by chain, they combine together. The Python interpreter starts at line 13, evaluates the code. If it's true, then the associated code block will be executed. And then if there are several Elif statements that follows, then they will be swiftly ignored, and then the control flow of the program will jump to outside of the last else block, which I'll assign line 22. Let's go ahead and run the program again. So Shift plus F10 to rerun. So if we pass in 88, then we'll see that if final grade is greater than 90, so 88 is not greater than 90, so therefore line 14 is ignored, and then the control is passed to line 15, and then Elif final underscore grade is greater than 80, then in that case 88 will be true because 88 is indeed greater than 80, and therefore line 16 will be printed. And then since one of these expressions evaluate to true, then the remaining Elif statements will be ignored, and then the control will pass to outside of line 22. So use Elif statements when you want to chain or combine multiple conditional checks, and you only want one statement to evaluate if its corresponding expression reduces down to true. So we learned how to use Elif statements in this lesson, but there are still some things that we can improve upon. What happens if we rerun this program? And what happens if we put something like -100? This input makes it into our program. Or what happens if we rerun it and pass in something like 200? Again, this makes it into our program. Sometimes we want to put constraints on what the user can provide into our program. So we'll learn how to check for these edge cases or to check for undesirable results that could lead to unpredictable programs.